Hi there everybody, welcome back to Building the Mesa camper. We're on part 6 now, where this is where we're going to install the 120 volt AC electrical system. If you missed part 5 where we did the 12 volt DC part of the electrical system, you might want to go back and go to that part and watch it first. I'll give you a better idea of what's going on. Anyway, it's time for us to do the 110 volt side. And I have my shoehorn in my pocket, and we're going to try and get all of this installed into that little bitty cabinet and make it work. Okay, of course, in order to do that, we have the plan. This is the entire plan. I'll go into detail with it here in just a second, and we'll get started because that's what we need to do. The weather's getting cold, and I need to get this done. So, tag along. We're going to do the whole thing coming up next. Okay, here's the plan as it exists at the moment. This is what you saw on the last one. All the orange is 12 volt DC. Over here on this side under the cover is all the 120 volt AC, and that's in yellow. So this stuff here is all done already. See part 5. Now we're going over here. And what you see over here, this is the AC side. We have an AC DC 30 amp charger. So that's why it's going from AC to DC. And we also have an automatic transfer switch. It will transfer the 115 volt coming in and go to the interior outlets, or it'll switch back and forth to the 1000 watt inverter, which will provide 110 volt AC to the internal outlets. So what the internal outlets get depends on whether this plug is plugged in or not. If it's plugged in, that has priority to the switch, so it'll come through circuit breaker, an internal connection box, and to the switch. Okay, and then out to the outlets. If I pull the plug on that, we're left to internal power. Now we're coming off the batteries here, and we're coming to the 1000 watt inverter off the batteries, and then from there to the switch and over to the outlets. So it'll either be one or the other. That's what we're looking to do. Very simple. Only got 3 major things to install. Well, 4 if you count this circuit breaker. This is already installed. That was done on the original basic install. So we'll put in a 15 amp circuit breaker in line with the power source. And this is a little connection box. You always have to use a connection box with 120 volt circuits. You can't just tape them together like we do with 12 volt DC. So connection box. And now it's going to split into 2, so we'll provide power to the 30 amp charger and down to the switch. Okay, so we have the circuit breaker, the 30 amp charger, the switch, and the inverter. Those are the things we're going to install. Okay, you've seen the plan. It's time to go do it. Oh, and just to keep things a little briefer than we have been, what we're going to do is, you've seen me pull this internal box out of here, the sitter bench. Well, I'm going to just go ahead and do it and set it on the table, and that's where we'll come back to. Okay, here we are. In order to fit all this stuff in, we're going to have to put it where the other stuff is not. So that means we're going to start here with the circuit breaker for the shore power. It'll be sitting right about here, just like that. So it'll go in there just to the right of that hole, and about there. That means this line's got to move. We're going to have to make another one. So let's get to it. There you go. That's not going anywhere. The next thing we install is going to be this three-way junction box. It comes from the circuit breaker over to this input, and here it'll split into two. One of them will go to the battery charger, and this other one will go over to the three-way switch, the voltage sensing switch, to provide shore power to that inlet. And then the next thing we put up after this goes up will be the three-way switch right over here. Okay, let's get busy on that. Okay, we're continuing our circuit going from the shore power input through the circuit breaker, from the circuit breaker over to the tie-in box, and the next thing that goes in here, this is the three-way switch. Now, so you can read it, it's that way, but it's going to mount upside down, mostly because this line here has to go into that box, and this line here has to go that direction to go through this bulkhead over to where the inverter is going to be. So it's going to mount right here. Guess we'll get on that. All right. Got them marked. Get the screws installed and get this thing mounted. Okay, got power going that way, and that's going that way. This one's going into this box. Tis it is. Okay, here's the job in progress. The shore power coming in will plug in here, which comes out over here in the bottom right corner and comes up into the circuit breaker. From the circuit breaker over to that plain old junction box, one power coming in, two going out. One goes to the three-way switch. The other one is going to go, that isn't in it, right here, is going to go to the 30 amp charger, which is right here, and will get mounted right about there. Okay, so the charger's coming up next. So you saw it in the diagram. It's just a line going from here through the switch, or through the circuit breaker, to the junction box, to the three-way switch, and to the charger. That's where we're at so far. Okay, looks like that will do it. Got to finish the wiring. Got to put the red and black 10 gauge wire from here onto this and go back over here to the bus bars. That's next. Okay, for the 30 amp charger, we're using another Victron energy component. They're one of the top of the line products, and they're still relatively inexpensive. This 30 amp charger, it's a smart charger. So just like the smart shunt that tells me everything that's going on with the DC system, this smart charger will tell me everything that's going on with the charging of that system. 110 volt input, 30 amps, 12 volt DC, well actually 14.5 volts for lithium, because it will know that it's hooked up to a lithium battery and work accordingly. It's completely self-contained. You don't have to monitor it or anything. It'll just take care of itself. It's also, since it's a smart individual, it is also works on Bluetooth on the Victron app that I already have on the phone for the smart shunt. This will show up on there too, so I can look at either one to see what's happening with it. So not cheap, but worth every penny. It's always good to know what's going on with your system. Okay, there's our battery charger. Now we have to run the power lead, the 110 volt up underneath this, like so. And we'll tie those off under there and run it over here into this connector up into here. Okay, it's all in place. I can't believe I got all that to fit. So again, through the whole thing, power in, comes into the bottom of the circuit breaker box, goes through the circuit breaker box to here, splits to these two, going to the three-way switch, and down through here to the charger. Okay. There's one more thing to do, one more part. Unfortunately, I don't think this is going to fit in here. So what we're going to do with this is we're going to not quite squeeze it in here. We're going to move it over here on the other side and move it on the back side of this wall and mount it right there. That'll be the next big thing. So that'll probably happen tomorrow. I'm going to go eat some supper. It's been a long day. See ya. Okay, we're back at it. It's been a couple of days actually since I gave you the last little video check saying I'll see you tomorrow. Well, things caught up. Had those things to do, so it's been a couple of days. I believe I last left off where we had got all this stuff in place and it was ready to wire in, and we were going to go from this box over to this side because over here is where we have to put the inverter. There's no room to put it anywhere else. So while you were gone, I went ahead and finished all the wiring on this side, got it all lined up, ready to go. and pushed the wires from this side for the inverter through this wall and into this side, and got them all hooked up over here and ready to go. And then I did some carpentry work, made some of these, and basically these are, this one's a brace for the outlet that's going to go in the front there, and I put another one on this wall as a cable run to run some big 4-gauge wire from the bus of the shunt back through here, through this wall and into the inverter. So that'll be coming up in a little while. But I thought, just for the heck of it, that you might like to see what actually is involved in this one piece of wood, which is a mounting brace against the front wall over here to put the outlet in. One piece. You're about to see what I had to go through to make one piece. And people think that these jobs are simple. They're not. You know, each little step along the way has its own problems, but also it takes time. I mean, all I did, this is a piece of 1x2, okay. I had to cut it to fit that and then make all the adjustments and everything to make it hold the outlet box. You'll see, it took probably 20 minutes, 30 minutes just to cut this and get it ready to put in. You watch that and I'll get ready to do something else over here, okay? I'll see you in a couple minutes. Okay, we're back in the real world now. So this piece is going to mount down here, and but first, in order to do that, I have to mount the junction box that the outlet's going to go in on here, and then glue this and mount it to the wall and the frame down there. So even more stuff that has to be done before we can get this outlet installed. Might as well get started now. All right. In the previous clip where you saw me setting all this stuff up, I had pre-drilled the holes for this box to temporarily mount it on here so I could set it where I wanted it to be and then mark the front panel to where I needed to cut it. And then as soon as I did that, promptly I had to take it all apart to paint it. So now we're going to put it back permanent like and call it good. Okay, on outlets, a lot of people wonder how you hook them up correctly. Well, if you look at an outlet, there's two blades and a pin. The pin is always the ground, and on wiring, green is usually ground, either green or a bare wire. And you have the two slots. You got a big one and a small one. Okay, just to make it easy, power side is the small one. This is the neutral side or the return side, the big one. So small ones is the power, big one is the return. But if you look on the side of the outlets, this side's brass, this side's silver. So you got silver screws, brass screws. So the easiest way to remember this is you look at an outlet and go, okay, black to brass. Black is the power lead coming in most of the time. It goes to the brass side, the power side, the small slit. Okay? And green, of course, is the ground. Green's the ground the world around. And then that leaves a white. White is the return line or neutral. It'll always go on the big side. Again, where the silver one's at. Black to brass, white to silver, and the green will be down here, because I got the screw in my hand, for the ground. Okay? All done. Okay, it's done, finally. Everything's done. The whole 125 volt system. On this side, our inverter is mounted in place. Outlets in place, so all the wiring's done. This big black cable here goes from the inverter over to the smart shunt. And this red one will go to the battery that sits right here. And the two batteries are connected with number 4 cable, which is good for 100 amps or more. And we'll be good to go. The next thing to do is to do a dress rehearsal. I'll get the batteries, put them in. We'll get everything wired up just like it would be in the truck. And we'll see if it's all going to work. That'll be next, but it won't be today. It's getting late. Thanks to the time change, it's, my clock says it's going on 5 o'clock. Got a little sun glare right on it. Yeah, it's quarter to 5. And it gets dark at 6. So we're going to call this good for the day. And tomorrow I'll get back to it, get all this set up and give it a dry run here on the bench and make sure everything works. See you then. Okay, we're back. It's time for the big reveal. The master test to make sure all of this stuff is going to work. I have got everything set up for testing, and my little items are going to test through the outlet. We have a voltmeter. To the right of that is the remote control to start the inverter. My phone is using the smart shunt to show me what's dealing with the batteries. And all of this stuff down the line to the circuit breaker here is where we're going to test. And come around here to the other side. Down here is where we have the input, our shore power connection, being input into the circuit breaker. So that's going to simulate a generator or a plug-in at a campsite or something like that. Okay. We'll come right back here in just a minute after I've repositioned cameras, and we'll get this test started. Okay. We begin the test. We have 0 volts at the outlet. The inverter is not turned on. And my phone is telling me that we have 13.8 or 28 volts on the battery. It's outputting 0 volts and 0 watts, and it's not charging. So we'll come over here. Let's turn on the circuit breaker. I heard a click. We now have 120 volts to our outlet, and the phone is showing me that the charger is working. Our battery voltage is 13.45 and it's charging at 29.84 amps. So right now the batteries are charging 400 watts worth. So our 30 amp charger is doing its job just like it's supposed to. Alrighty. So we have our voltage to the outlet. Now I am going to come over here and close this circuit breaker. This is the 100 amp breaker for the inverter. So we will turn it on. Our inverter is turned on. It's showing 13.5 volts, but 0 volts out. Reason being, we still have power available to the switch here, so it hasn't switched over to the batteries yet to provide power for outgoing stuff. So if I turn off the circuit breaker and suddenly we're without that power, ta-da, 120 volts again. Now we're completely on the batteries. Right now, we're just idling. We have 0 output on the inverter. It's just sitting there doing nothing. So output current is about 0.6 amps. So let's put a load on it. I have a kilowatt meter here that is showing on the outlet 119 volts. So I'm going to turn on my heat gun here. 124 volts. And 575 watts out. It should be 60 amps or so. Let's go look at the phone. Yeah, phone is showing 51.5 amps going out of the battery and pulling 667 watts out of the battery. So that's about 100 watts difference what we're getting on the kilowatt meter and on the battery for a reason. Inverters are not 100% perfect. At best you get about 85% of what they're rated at, because the inversion process uses up quite a bit of power. So we've lost almost 100 watts. So we're outputting about 100 watts more than we're actually getting at the outlet. Simply it's going to be wasted because this inverter is going to get nice and warm, and all that heat, the extra stuff is going to be radiated away as heat. But the big thing is, it's working. Woohoo! Everything's working the way it should. Now if I switch back to the shore power, everything shifts over. Still outputting 538 watts. But go back to the shunt here. And now, instead of a minus power going out, we get a positive telling me that it's charging at almost 30 amps at 400 watts. So by turning that switch, we got off the batteries onto shore power. The three-way switch turned over here, and now We get our 535 watt load is being run off of shore power. It's not the inverter. The inverter's still got voltage, but it's idling. It's not doing anything. And our 30 amp charger is automatically switched in to start charging the batteries again. So if I shut that off, it's going to reverse that. All the inverter will come back up. The batteries will stop being charged and they'll start putting out power to the inverter. So it's a win-win. I like it. I'll get back to you guys in just a minute. Like I said, I feel like a kid at Christmas time. Everything works. All those hours of thought and planning and comparing things online of, will this battery output enough amperage for me to run the inverter? Do I need to get a smaller inverter? Will these play together well, and do these fight each other or whatever? Lots of planning goes into this stuff. You can't just go out there and buy whatever's on sale and hope it's going to work. For instance, I wanted a 1,000 watt inverter. I know that on a 1,000 watt inverter, it's going to draw about 90 amps or thereabouts at 1,000 watts. Okay, I need batteries that will, 100 amp hour batteries that will discharge at 100 amp hour capacity. Some of them do, some of them don't. So you got to buy batteries to match what you're doing with them. You can't just buy a battery because it's cheap on sale. Spend a little time, do a little research, and read the fine print on the specifications on all this stuff. For instance, these batteries that I bought have a 100 amp output rating, but the manufacturer suggests that you charge them in the 25 to 45 amp range when you're charging, even though their maximum input rate is also 100 amps. They recommend charging at about 40. So I bought my DC-DC converter with a 40 amp charging limit. See, they match. And the same thing with this charger, the AC charger. I didn't want to go overboard with that. I just figured a 30 amp one would be just fine, and it is. It works just fine. Everything plays well together. So one last test. I'm going to plug this 750 watt heater in, and we're going to see if our system is actually going to take care of it. Right now we're still on shore power, 120 volts to the meter at the outlet. The outlet is plugged into this extension cord, which goes to a kilowatt meter, and I'm going to plug the fan into that. Okay, here we are. Of course, this is going to work. And it says, the fan's on 750 watts. It says 678 watts actual. Okay, we'll run with that. 675 watts. Now, if I just lose shore power and I have this inverter in standby mode, if I do this, yep, switched right over. Did you hear it? So at load, it was 120 volts on shore power. It's about 117.5 volts. So you got a slight voltage dip there, a couple of volts. Not going to make any big difference. And we're at 685 watts out. Looking on the smart shunts, telling me how much is coming out of the batteries. 60 amps, 59.85 amps coming out of the batteries at a total of 776 watts. There you go. It's working just fine. Oh, I love it. I love it. I'm a happy camper. Alrighty. It works. Well, one more thing. Just a caution. I know I've said it before, but if you've never done this sort of thing, don't even think about doing it yourself. It can get very complex. It's not just throwing a bunch of parts together. You have to think about it the whole way through and plan what you're going to buy, how big is it, how well is it going to fit, and how are you going to charge it and discharge it and make it work. For instance, this inverter is the biggest power, I know I said it, it's the biggest power hog you're ever going to have in a system. There's a reason why when you go to RVs that their air conditioning does not run off of 12 volt DC. Because that's another huge power hog and it's not efficient to run it on 12 volts. So here I'm running a 750 watt load off of this inverter, and it's pulling almost 800 amps out, 800 watts out of the batteries. I have 2100 watt hours of batteries here. Oh gee, I could run my inverter for 3.2 hours. Okay, yeah, you can do that. But what happens when you stop and those batteries are dead? How long is it going to take you to charge those batteries back up? I guarantee it's going to be a heck of a lot more than the 3 hours that you just spent staying warm running your heater. It might take 12 hours or 14 hours to recharge those batteries if you have a good charging system. So it isn't all about how long you can run stuff off the batteries. The real thing is how quickly can your batteries be recharged and recover from that big load that you just had on them. That's even more important. Charging rates can make a huge difference in your outdoor experience. If it's pouring down rain and it's no solar is available and your batteries are down to 20%, what are you going to do? Are you going to sit there and let your truck run at idle for 8 hours to recharge your batteries? Or do you have a small generator that you can run, a little 1,000 watt generator you can run and do the same job? See, you got to plan this stuff ahead of time. So I hope you enjoyed all this. There's times when I didn't enjoy it because some of this stuff was just so aggravating, I just wanted to throw stuff. But everything fits in the end, everything works, all is good. And thank you for sticking around this long to make see all this stuff work. I only have one thing to do. Now I have to put all this back out there in that truck. The fun never ends. Oh, and just for the heck of it, my buddy Donald at Soft Growing the West just came out with a video on something that we had discussed several times about insulating the roof on our trucks. He just put new carpet on his ceiling. So I've seen that, and guess what my next job is going to be probably. Yeah, I want that too. We'll see what happens with the weather. Okay, thanks for being here. Enjoyed talking to you, and I hope I see all of you guys out there.